Hi everybody. Today we're going to look at a little bit of Python programming. This is not a Python programming tutorial, but Python is not hard to learn. As GIS cartographers, remote sensing people, we do a lot of repetitive stuff in our analysis. And this video shows on how you can use Python to automate some of these repetitive tasks. This is the first video in a series of automating this task that I need to do. Okay? So, I download and I read in Landsat scenes. And there's information in the meta file that is very important for the process, okay? And this meta file, like right here, has information in that file that is important to our task. Meta file is data that describes data, okay? And in this file, down at the bottom, toward the bottom, there's values that are of interest in the mathematical analysis of a scene. And I need to extract this information out of this meta file. And how I'm going to use that is I'm going to write the results of this, reading this file, and I'm going to write those results into a database file, just a simple dbF. And that dbF I've created is called InSatProcess. And like I said, it's just a simple database file I've created in ArcGIS. We open it up. Notice that there's nothing in it. But I have a sat field, a value, a band, a type, and a class field. And I need to populate this database file with the information that's in that text file. All right, but that text file, the important field is value. And those values in that text file are in scientific notation for some of the values. And so what I'm going to do in this text file is write a Python script that converts them into decibels and then writes all the results to this database file that I can use for my next step. Okay? So that's what this video is going to show you, is that Python script. I'm not going to show you how to type it in because that would just bore you, but you'll see it on the screen that you can copy some of the things to your own workspace and get to know Python. I use PyCharm as my IDE. You can use any IDE that you are comfortable with. None of them are better than the others, in my opinion. They all basically do the same thing. You can even use a text editor to write this stuff as long as you have an interpreter on your computer. All right, so this is my Python script called the metaclean py file. Okay, and in the file there are variables that you set for paths and things like that. That's pretty standard in any programming that you do. And that's what you see right off the bat. The first thing that you need to understand in Python when you're using it with, in my case, this is ArcGIS that I'm using this particular script for, not QGIS. I could do it in QGIS. But I'm using it in ArcGIS, so I need to import the arcpy module for Python to use. And anywhere that you see arcpy nested into a variable is making a call to ArcGIS to do a certain function. Okay? The rest of them are just using the basic OS module that I've imported. Okay? Now, there's some other modules that I imported, but I ended up not having to use them. I found a different way to do that function. All right, so I have all these variables. The important variables to look at are file name, new file, OP, FP, and OP variables. These are just paths to my data, okay? And that's what some of these functions do, is making those paths and those variables. But we're pointing to a file called myTestMetal2 file, which is just a copy of that meta file that I showed you at the beginning. I'm stripping this file to only get me a few lines of it and write them to a file called myStrip file. And I'm only using the lines that are between line 165 minus the last 20 lines of that file. I don't need anything that's the last 20 or the first 165 lines. I want what's in between those lines. All right? With me? So this loop right here reads in my meta file, strips it out, and writes the results to the strip file. The strip file still has that scientific notation for all those values. Okay? The next step is I'm going to read in this strip file, and I'm going to create a new file. I'm going to create two new files. I'm going to create a new database file, a dbF file, and a text file that is basically the same thing as the strip file, except the numbers are converted from scientific notation to decimal. Okay? So we read in the strip file here, and for each line in that strip file, it creates lists. And that's what these are right here. These are lists, and they're empty lists, showing, notice that I don't have anything in these brackets. It's creating these empty lists. We're basically reading that whole line and breaking it up into little individual pieces, okay, for the data that we want to pull from it, okay? The first thing that we do is we create the lists. Then after we create the lists, then we start doing the work on the file. For every line it reads, it cleans the line up. That's what this line means, strip. Okay? We are removing characters that we don't need, which are white spaces and hard carriage returns and things like that, new line characters and stuff. We don't need those in our text file. We don't want those in our text file. So we read the line and clean it up. Then I do a test in that file to find the end of the file. I'm searching for a line that doesn't have anything in it. And if I reach that file, if I reach that line, then I'm at the end of the file. This part of the loop just gives me a clean way to end my program when it reaches the end of the file. The else is where it actually does all the work. Remember, up here, it split the line and it strips the line of anything unnecessary. This line, or these series of lines, this line right here, this strip line, it finds the equal sign and splits that line into two pieces. The part that's on the left side of the equal sign gets assigned to field, and anything that's on the right side of the equal sign, it gets split out to other parts, such as type, class, band, and things like that. Okay? The important field is the value. Okay, so a list, in this case, it splits the line into two pieces. The first piece on the left is assigned 0, index 0. And index 0 is the field name. Index 1 is anything that's on the right side of the equal sign, And one, actually down here under split line, one gets assigned value or val, okay? But val is in scientific notation. So I create another variable called nval for new value, and I use the formatting tool, and I convert that scientific notation into a decimal place with 7 places on the right side of the decimal. That's what this line does. And you have to convert this into a float, okay, or it won't work. So you convert the val, the scientific notation, into a float, and then format it into a decimal format, which is this right here. Now, it's doing this for each line at a time, okay? And then each line at a time, it basically appends to our text file and creates this field and takes this value and creates a line with field and value and band and type and class, okay? This line right here is, it's that file where we had the band number. It's just a report. It actually doesn't even use this file in its analysis. It's just for me. It's kind of like a receipt, okay? The next 2 lines is where it creates the actual data in the dbF file. The row is a value, is a variable that gets assigned a list. And that list contains field name, band, the new value, this value up here, type, and class, okay? And then this edit rows is actually the command in ArcGIS that writes row to the database, which is field, band, value, type, and class. And then these last 2 lines closes our original file and then stops the edit rows command in ArcPy. All right. Now, remember, I have no text file. I don't have that new text file or that strip file in my directory. That's going to get created when I run the program. And in Arc, this InSat database was empty. Okay? Now we're going to run the program. So in my IDE, I right-click on the name and I run. Now this is going to take maybe 10 seconds to run or so. Okay? But what it's doing right now is reading in that meta file, and it's cleaning it up. It's converting my scientific notation into decimal, and it's writing the new results to the text files. And and I had a bunch of print statements in there just so we can see the process getting done. Bands 1 through 9. Okay, so it has finished running that program. So if I look at my directory, I now have a new file. I have a new file and I have a strip file. The strip file is that meta file, just stripped out with the lines that we only are interested in, but it still has a scientific notation. All right. After it wrote this file, it writes a new file. And that new file is right here. And it's cleaned up. It gives me my band number, my field name, and now my numbers are in decimal using that formatting tool. Okay? The next step of the program reads in this file now and strips this out band number, gets multiple for the type, and it gets radiance or reflectance for the class, and it grabs the band number and it grabs the actual value that I want and writes those to their individual fields in the database. And so if we go over here to ArcGIS and open that dbF file, it's now populated with all the information. Okay, so here's the original field name, and then there's our new value converted to decimal, and it stripped ban out of that field name and put it in its own field. It took the multiple or the add and put it in its own field for type, and the root name of this field, radiance or reflectance, and put it into class. Now I can use this dbF file for the next step, and that next step we're going to show you in the next video. So I hope you liked seeing what Python can do with a text file in writing a dbF. The next video will be the next step, so be sure to subscribe and hit the notification bell so you can see when I upload that next part of this series. Anyway, you guys, everybody have a great day, and thanks for watching.